This is the geography lesson called The Rotation of the Earth and Its Consequences. Materials you will need for this lesson. You don't really need much. Just sit back and maybe you want to take notes with a paper and some pencil. You can always refer back to this video as it is posted in the Google Classroom. So when we think back to the great story that you heard last week, we think about the darkness and the coldness that was space, and that flaming, fiery mass that traveled through space, leaving its tiny droplets. Well, one of those tiny droplets was to become our sun, and another one of those droplets eventually became our Earth. And now when the Earth came into its being, with all the rocks and the plants, the trees and the animals, the Earth was moving around the sun. Kind of like these keys are moving around my head. The Earth goes around the sun in a counterclockwise direction. And it keeps going on and on around the sun, just like it did once the Earth was set into creation and its being. Now the Earth has another movement as well though. The Earth also travels around itself. So just like myself, standing around, rotating around myself would look like this. So I'm going around myself and around the sun. And well, that's a really easy way to get dizzy, so I'm gonna stop there. But when the Earth was born, it was so happy. So it did that dance around itself and around the sun, and on and on and on, our Earth still keeps moving in that way. So when we think about this summer, think about how hot it was this summer. We see the sun, and we think about how hot it can get and how it feels as though all the rays of the sun are hitting us and it's just so hot. But the reality is that only part of the sun's heat actually makes its way to us here on Earth. Only 2/billionths of a part of the heat of the sun makes its way all the way to Earth. It's because the Earth is so small and so far away that we don't get as much of the heat. In fact, but if you think about it, even though it's only 2/billionths, which if you think about it, that's really small amount compared to the whole of the sun. If the Earth didn't turn around itself, we'd have an Earth that looked like this, where the side of the Earth that was facing the sun would be so hot, it would be inhospitable. No one could live there. No people, no animals, no plants, no nothing. But then the other side of the Earth would be a frozen, cold icicle. Nothing could live there either. So that's why it's so important that the Earth turns around itself at the rate that it does. So let's look at how that really works here with our globe and our light here. So because our Earth is turning around itself and going around the sun, you can see this really well actually right now, that only half of the Earth at any given time is exposed to the light of the sun, and while the other side is in darkness. So just as the Earth turns around itself and goes around the sun, only half of that Earth is illuminated by the rays of the sun. Now, you could even pick one spot on our globe here, and I'm gonna find here. Right about here is where Milwaukee, Wisconsin would be. And so right here you see, if we keep going around ourselves, okay, we're back, and we are seeing that Milwaukee is just coming into the light. And so for us, the sun is just rising up out of the sky over Lake Michigan. And as the earth keeps turning around itself, as our day goes on, we do our school, we eat lunch, and then we have our afternoon lessons, and then we have the end of our school day. We go home and we have dinner, and the sun starts to fall in the sky. It's no longer as high as it was. And then we see our sunset, and we know that the sun is no longer shining on us right now because the part of the earth that we are on is no longer illuminated by the light of the sun, but another part of the world is. So, in reality, even though it looks like to us as though the sun is moving, we know through that demonstration that that's not actually the case. It's the earth moving around itself, but also around the sun. So if you take a look at this chart, here we see, we can kind of see through the coloring what we would expect here. So counterclockwise, yeah. So we see the sun directly shining upon one part of the earth, and that time would be noon or the midday, right about when we're eating lunch or just finishing up with lunch during our virtual school schedule. And that stands out because it's in red. But as the day keeps going on, we reach our sunset, and then we reach our night, and then our dawn, and then back to noon. It's an endless cycle. Now with this chart, we can see the reminder that that trip that the earth takes around itself takes right around 24 hours to make that trip, that one rotation around itself. We can see these numbers here. When the sun rises, it is about 6 o'clock in the morning. As the sun gets higher in the sky, we go through our morning hours. And the sun gets higher in the sky and higher in the sky until we reach noon or midday. And the sun then starts to get lower in the sky, and the temperatures start to cool. Here we even see this on our clock. 12 o'clock, this says 13, 14. These are the hours in the day. So 13 would then be 1 o'clock, 14, 2, continuing on. And then the sun sets sometime around 6 p.m. And think about it, when is the coldest part of the day? It's actually just as the sun is coming up, mostly. But we know here in the Midwest, weather is always all over the place. But yeah, that's what I wanted to say about the rotation of the earth today. Thank you.